Hi folks, welcome back to Math with Captain Rod. I'm making this video here to help you out a little bit with how to apply exponential growth models. So the example we're going to go over is something I think about a lot. You know what has happened in the Florida Everglades, and I made these numbers up completely off the top of my head here. These are not accurate, but you know, the Everglades has been filled with pythons. So what we're going to do here is we're going to go through this example. If there are 200 snakes in a certain region, maybe it's the Everglades or somewhere else in 2010, and 700 of them in 2015, how many would we expect by 2025? So snakes are something that they reproduce continuously. And this is the type of thing that we would not want to apply a linear model. We would want to apply an exponential model. So we might start by saying, all right, the amount that we have is equal to some initial amount times e to the kt. This is a really common method for modeling exponential growth. Now we have to choose a time to measure t from, right? We don't want to use 2010. It just makes the model much more complex. What we're going to do is call the year 2010 t equals 0. And then in 2015, this one would be t equals 5. And then in 2025, this will be t equals 15. All right, and we're going to start by applying this. We know that the amount is 200 when t equals 0. So if I take this formula here and rewrite it, it's going to read 200 equals a sub o e to the 0. Now e to the 0 is 1. So what this tells us is that our a sub o, if you will, is 200 snakes. So we kind of update our model. So now it's going to read a equals 200 e to the kt. Now the other thing we need to do is we need to figure out this guy here, this k, and that's a constant that affects the growth rate in our model. What we're going to do now is apply our second condition here, this one. When t is 5, the amount is 700. So this is going to read 700 equals 200 e to the, now by the time we put t in, 5 in for t, this is going to read 5k. I'm just reversing them because 5k sounds a lot better than k times 5. And now what we need to do is solve this for k. First step would be to divide by 200. Let's see here, and I think we're going to get 3.5 out of that. And we take 700 divided by 200, so we're going to have 3.5 equals e to the 5k. This is then solved by taking the natural log of both sides. So now that's going to read natural log of 3.5 equals, now by the time we take natural log of this thing, what we end up with is 5k. Let me go over that again, because the natural log of e to the 5k is equal to 5k natural log of e, and natural log of e, this thing, is equal to 1. All right, so our growth number here is going to be natural log of 3.5 for 5. Now this is just some number, and I don't have a calculator handy. I'm just making this video to help you figure out how to work these problems, but typically I would at this point get a decimal. Then what we do is we take this value. Now again, keep in mind this is a known number. We put that into our formula. So our new formula for modeling is going to look like a equals 200 e to the kt, and again, where k here is some number that we would have. All right, now the next step would be to put t equals 15 in for here, and you'd get a value. The other thing we could do if we wanted to is maybe somebody said, oh, well, at what year will we have, say, 1,000 snakes? Well, then what you would do is you'd put 1,000 here and then solve this for t. So that's pretty much how you apply the exponential growth model. I know that was not done to completion, but that should be good enough to help you out with your homework. Hope that you have a great day, and I hope everybody's staying safe.